சொல்லணுமா?
Happy morning, Mr. Rakesh.
Good morning, sir. Good morning, sir. Good morning, ma'am. Shiva Shakti, ma'am.
Morning, Rakesh.
Good morning, ma'am.
ভালো আছে?
ভালো আছি।
ঠিক।
Rakesh sir, good morning. Now you are a host.
Okay, ma'am.
Yes, yes.
Okay, ma'am. Thank you, ma'am.
A very good morning, Makhan sir. আপনি আছেন? Makhan sir? Rakesh? Mr. Rakesh?
Yes, ma'am.
হ্যাঁ হ্যাঁ মাখন স্যার শুনতে পেয়েছেন আনমিউট করে দিয়েছি দাঁড়ান
আচ্ছা।
আচ্ছা গুড মর্নিং মাখন স্যার এদিক থেকে হয় না আনমিউট
না, হয়েছে, আনমিউট হয়েছে।
হ্যাঁ হচ্ছে মাখন স্যার পারছে না মনে হয় না
পারছি না মনে হচ্ছে।
হ্যাঁ ঠিক আছে এদিক থেকে তো হয় না আনমিউটটা
না।
Hello.
হ্যাঁ হ্যাঁ গুড মর্নিং স্যার
গুড মর্নিং স্যার।
Good morning, Rakesh Babu. Good morning, madam. Good morning.
গুড মর্নিং শিবা শক্তি
Good
ম্যাডাম
morning.
Hello, Ravi sir.
Yes, madam, we are on. Tell me, ma'am.
Makhan sir is one of our society member. Makhan
Oh.
Kundu sir.
Good morning, Makan sir.
Good morning. Good morning, sir.
Good
Good
morning,
to
sir.
Good morning.
Good morning, sir.
Morning.
Makan sir, good morning.
Good morning, madam.
Good morning.
Your video is not on, sir. So can we just have a look?
Good morning.
আপনি ভিডিওটা অন করতে পারবেন স্যার
ভিডিও তো অন করাই তো।
আমি করে দিচ্ছি আমি করে দিচ্ছি দাঁড়ান
করে দেন।
আপনি করুন এখন করুন আমি
Good morning. Good morning, sir. Good morning, madam.
গুড মর্নিং
Good morning.
মাখন স্যার শুধু ভিডিওটা আপনি ক্লিক করে নেন ভিডিওটা
ভিডিওটা ক্লিক করব এই যে হলো এখন
হয়নি
এবার
হ্যাঁ
হ্যালো
হয়েছে। হ্যাঁ, নমস্কার
গুড
স্যার।
মর্নিং এইবার হয়েছে
গুড মর্নিং স্যার।
মর্নিং গুড মর্নিং এভরিবডি
Morning.
Happy morning.
Yes,
Nice
sir.
to see you here.
হ্যাঁ
গুড মর্নিং স্যার গুড মর্নিং
Come in.
স্যার ভালো লাগছে না সব প্রোগ্রামগুলো
হ্যাঁ শুনছি তো
হ্যাঁ
প্রোগ্রাম ফাইন হচ্ছে
হ্যাঁ ধন্যবাদ স্যার
Good morning, Sharmishta madam.
Good
morning.
Good morning. Good morning.
Happy
Shiva
to,
Shakti ma'am.
Sir, good
Sharmishta
morning.
Das is our faculty member.
Sir,
Morning.
Uh, Mrs. Sharmishta Das is our faculty member from Dhupuri College of Education.
Shivashakti madam,
yes, ma'am.
I've added Sansawal sir. So he's already there. I've added.
You added?
Yes, I've added.
it's always better to see the happy, smiling face on our screen. So thank you very much for showing your smiling face, Dr. Vasif, Mr. Rakesh, and everyone.
Thank you, sir. Thank you.
Yes, sir. Acha.
Dr. Dayanand, sir, good morning.
How are you?
Good
morning, Dr. Dayan.
ভালো হয়েছে আমি কেন ও আচ্ছা
Good morning, Bobby madam.
A very good morning, sir. A very good morning, sir.
How are you?
Dr. Dayanand, sir, good morning.
Good morning, madam. How are you, Raj?
Morning. Fine, sir. How are you, sir?
Okay, trying to survive in COVID-19.
Good morning, sir. Good morning, Dayanand sir.
Good morning, Roy sir. How are you?
I'm fine, sir.
Very good.
Shivashakti, madam,
Yes, ma'am.
you just let me know when to begin, okay?
Okay, ma'am. Ma'am, 12 o'clock, ma'am.
It doesn't matter. It doesn't matter. I'm there.
We will start, ma'am.
It's already 12. So she meant to say we can start.
Yes, we will start.
Oh, okay. We can start.
Because
Can
everything
start.
is all right. The live streaming is going on, so we can start.
Fine, sir.
Sir, we can start?
Yes. Please go ahead.
Okay, sir. Okay.
At the very beginning, I would like to say I've learned a new word of Tamil, that is Varapverpu, and a warm greetings to one and all.
Nandri.
I, on behalf of Tamil Nadu Teachers Education University, Chennai, and Dhupuri College of Education, Jalpaiguri, West Bengal, would like to welcome Professor Dr. Dayanand Sansawal sir to the 5th day of international webinar on research methodology and applications of statistical tools to deliver the remaining part of hypothesis. We all agree that yesterday's session was extremely informative. It was a descriptive presentation with detailed explanation. You also highlighted the concepts with simple, lucid examples. We all strongly agree that it was indeed a useful session for all of us. I once again take the pleasure to introduce our eminent speaker, Sir Dr. D.N. Sansawal. He retired as a head and dean, Faculty of Education, Devi Ahilya University, Indore. He holds MSc in physics and PhD education degrees. His area of specialization are research methodology, experimental design, advanced educational statistics, educational measurement and evaluation, educational technology, science education, computer education and information and communication technology. He has taught business research methods and quantitative techniques in IIM Indore from 2004 to 2008. He also taught business research methods in Indian Institutes of Foreign Trade, that is IIFT, New Delhi. He has published extensively both in Indian and foreign journals of repute. After retirement, he has conducted 180 workshops of 7 to 15 days on research methodology, statistics, and use of SPSS all over India. To note, he has given 80 webinar lectures on different topics, including research methodology, statistics, and use of SPSS. He has invented jerk technology, multiple discriminant type items, multiple answer type items, educational clinic, etc. Dr. Sansawal sir was given the Best Teacher Educator Award by All India Association of Teacher Educators India. Just for a general information, Sir has already published a book on research methodology and applied statistics. I repeat, a book on research methodology and applied statistics. It is published by Shipra Publishers, Delhi, and it is readily available in Amazon and Flipkart. So if anybody wishes to purchase or get to know more about research methodology and hypothesis, whatever it is, so they can readily avail. So I most humbly request Sir to take over the session. Madam Shiva Shakti, Madam, would you like to say something?
No, ma'am, no.
Okay, so, Sir?
Okay. Thank you very much. Thank you.
Thank you, sir.
All right. My dear friends, very good morning to all of you. Yesterday, I had given you few informations, and these informations were related to the different aspects of the research, and especially it was the hypothesis. And by chance, if there is a question which you would like to ask related to whatever I did yesterday, I will be too happy to help you. Now, I have given you the definition of hypothesis. Then I gave you the basis of formulation of hypothesis. Then I told you the types of hypothesis, and I told you the forms of hypothesis. Along with this, I did tell you the wording of the hypothesis. Wording of hypothesis, I told you. Now today, I am going to tell you the testing of the hypothesis. And when I go to the testing of the hypothesis, I like to tell you the two important concepts. One important concept is a degree of freedom. Another important concept is level of significance. And you know, normally these two concepts are not properly understood by the people. So these concepts, you must understand it properly. So after testing of the hypothesis, I will tell you that type 1 error and type 2 error. What exactly is a type 1 error and what is a type 2 error? And can a researcher avoid the error? This number one. Number two, of these, which error is most dangerous? See, all errors are errors and they are definitely not welcome. But which one is more dangerous than the other? So that's what I will try to tell you. And towards the end, I will tell you there is what is called one-tailed test and the two-tailed test. There is a lot of confusion between the one-tailed test and the two-tailed test. So today, this is what I will like to focus on, the red part. And I will definitely tell you that if there is a time, I will take different objectives and will tell you how the hypothesis must be formulated, because there is a lot of confusion and lot of people make mistakes in forming the hypothesis. Yesterday, a question was asked that can there be more hypotheses of a particular variable, a particular objective? Well, it depends. I will tell you and give with examples so that you start understanding. Now, let me tell you first I will tell you the testing of a hypothesis. In that testing of the hypothesis, the one important concept is the degree of freedom. I'm sure you know the meaning of the freedom. What exactly is a freedom? Just think about it. What do you mean by the freedom? The freedom means the total available options or alternatives. That is the meaning of freedom. That means the total available options or total available alternatives. I'll take example. If you talk about the sleeping, how many hours do you have total number of hours given by the universe to the human being for sleeping? Just think. I'm sure you have thought and you are thinking that it is 24 hours. So the total available freedom to the human beings to sleep is 24 hours a day. You can't sleep 25 hours a day, but you can always sleep 23 hours a day. Less you can sleep, but more than that you cannot sleep. Okay, this is one example, the meaning of freedom. The meaning of freedom is, if suppose I have 6 shirts So what is the freedom which I have to select the shirt? The total freedom is only 6. I cannot have 7 because I do not have the 7 shirts. Suppose at home, the only 2 vegetables are cooked. So what is the freedom that you have to eat? The total freedom is only 2. You can't have 3. Okay, so that is the meaning of the total freedom and total available options. So that is the meaning of the freedom. Do you think that all of us have infinite freedom? I'm sure you will say we do not have infinite freedom. The freedom is always to a particular extent. Okay, so that means there is always a degree of freedom. Now, once I say the degree of freedom, what does it mean? It means that there are certain restrictions. And when you have the restrictions, that restriction or restrictions will going to reduce your freedom. And when it reduces freedom, then it has to be subtracted. So we are subtracted the total restrictions imposed. You know that when we are not well and we go to the doctor after examining will give the medicine and he will side by side tell that you do not eat this and this and this and this till you are taking this particular medicine. So what the doctor has done? The doctor has reduced my freedom of eating. Okay, and why he has? Because he has put some restriction. Imagine when you were young and not married. Do you think that you have enough freedom to sleep any length of time, to eat anywhere you like? Absolutely no problem. And after you got married, do you still enjoy the same degree of freedom? I think you will agree that you do not enjoy the same degree of freedom. It is less. Okay, and when you have children, the degree still reduces. When you are young, maybe having little more freedom, but as you aged up, then your freedom keeps on reducing. So the degree of freedom means the total available options or alternatives minus the total restrictions imposed. You know, the government, they have the rules. When you are driving on the road, there are rules which each and every person who is driving, he or she has to follow those rules. What those rules do? They reduce your freedom. You cannot drive on the road as per your choice. Absolutely no. You have to follow the rules. In India, we have to keep the left-hand side because we have a left-hand side driving. If you go outside in some other country, they have a right-hand side driving. So therefore, when you go in that country, you can't drive in the left-hand side. You have to drive on the right-hand side because that is the rule. So your freedom is curtailed. So whatever the rule you have, these rules are going to limit your freedom. I'll take the last example from daily life. You see these small children, they want to go to play out in the evening. And normally the children, they ask mother, mommy, can I go out to play? Then the mummy may ask, have you finished your homework? He may say, yes, I have finished my homework. Then the mother will say, you go to play out, but do not go too much away from the home. This is the one condition. The second condition the mother may put is you come before the sunset. Now, when the mother is saying you come before the sunset, this is the restriction which the mother is putting on the child. So therefore, the child does not have enough freedom. His freedom is reduced. And dear friends, you will find that as you think more, you will find that hardly you have a freedom. At home, you have to abide by the rules of the family. At your workplace, if you are in a college, you have to follow the rules of the college. When you are on the road, you have to follow the rules of the traffic. Understand, anywhere you go, do you have the freedom? The answer is yes, but only to a very, very limited extent. It's not infinite. Okay, so that's what is the meaning of the degree of freedom. And degree of freedom is denoted by DF. And D has to be small and F has to be small. Now just see, the moment I pressed, this D became capital, so you have to change it to small. Sometimes such, I do not know whether you will call it a silly mistake or you will call it a mistake, I don't know. But such type of mistakes are normally found in the thesis. And that should be avoided. It's not very difficult to avoid it. So the DF, I'm now taking example. Suppose I have 5 shirts. So total available freedom or total available alternatives or total available options are 5. And suppose one shirt is dirty. So my restriction is 1. Therefore, my degree of freedom becomes 4. Why? Because 5 is the total, available options, and 1 is the restriction because one shirt is dirty. Okay. If suppose I have the 5 shirts, okay, and my one shirt is dirty and another is not ironed, so it is -2. So now it becomes, so if you increase the restrictions, your degree of freedom keeps on decreasing. Now the question arises, can DF be 0? Because if you keep on increasing the restriction, a stage may come when the value becomes 0. Now the question arises, do you think that the degree of freedom can be 0? And if you think it can be 0, then tell me why. And if you think it cannot be 0, then think why. If you want answer, I can give you the answer. See, if you say the degree of freedom, the moment you say degree of freedom, it cannot be 0. Because when it is 0, then the freedom is not there. And if there is no freedom, then you cannot say degree of freedom. So therefore, the degree of freedom can never be 0. But the minimum value of the degree of freedom is 1. It has to be 1. If I have the 5 shirts, all 5 shirts cannot be bad. I have to wear 1 shirt. So therefore, there must be 1 shirt which I can wear. If there is no shirt to wear, then what will I wear? And as a human being living in a society, I have to wear the shirt. So therefore, your degree of freedom can never be 0. And I repeat the reason. Because if it is 0, then it means you do not have a freedom. And if you do not have a freedom, then you cannot call degree. The moment you say degree, then the freedom must be minimum 1. So that's the important information which I am giving you. Some of the books may not give you this type of information. All right. Okay. So that's the meaning of the degree of freedom. Let me use this particular concept and we'll see how it can be used. Suppose I have gender as a variable and I have males, okay? And suppose I'm taking the weight of the males. Okay, suppose I'm taking the n number of males. If I say suppose the number of males are, let us say 42. If I say take the weight of 42 males of 20 years old so that their mean weight becomes, so that their mean weight is equal to 45 kg. I repeat, suppose you take 42 males of 20 years old and you take their weight so that the mean weight becomes 45 kg. So therefore, what is the degree of freedom in this particular case? Just think about it. What is the degree of freedom in this particular case? Yes, the degree of freedom will be the the degree of freedom will be that how many people are there? 42 people. Okay, this is the total n. And what is the average weight? Must be 45. So there is only one restriction, that you can take any 42 people's weight, but the average weight must be 45. That means you can take any 44 weights, no problem, but your one weight must be such so that when you calculate the average becomes 45. So therefore your degree of freedom becomes 42 minus 1. And that means if you say this, it is 41. And if you say the 42 means what? 42 means it is N1. So you can put it is N1. Okay, so that means it is N1. And this N1, why? Because this is the total number and the minus is only 1. Suppose you have the females of 20 years old and you have the mean scores of the females, and suppose the number of females with you is, say, N2 is so N2 is, let us say, 55. So take the weight of 55 females of 20 years old, and suppose their mean weight, I'm just writing, if I say that their mean weight is, let us say, 42 kg. I repeat, I am taking the weight of 55 females so that the average weight becomes 42 kg. That means the 54 females' weight may be anything, but one female weight must be such so that when I calculate the average becomes 42. So that means the DF2. So DF2 is nothing, but it is 55 minus 1. I hope you are understanding. So that means when I say 55 minus 1, that means it is 54. And what is the formula? The formula becomes here that it is N2. So it is N2. So it is N2 minus 1. I hope you are understanding it. So if I find out in this particular case, my degree of freedom will be equal to DF1 df1 plus df2. So df1 plus df2 will be my total degree of freedom. And my df1 is n1 minus 1. So I can write something like this, that n1 minus 1, then it is plus, it is n2 minus 1. So it is n2 minus 1. Now, if you see this, then my degree of freedom, it becomes the n1 plus n2 n1 plus n2, then minus it is 2, because minus 1 and minus 1. This is the degree of freedom formula which you must be using, or you might have used when you analyze your data with the help of a t-test. Because in case of a t-test, the important is that you have a variable which has got two levels, and you want to compare the mean scores of on a particular variable of these two groups. Then the degree of freedom that we will be using, this is the degree of freedom which we use, and it is used for in case of t-test. It is used in case of t-test. This is important, okay? And when I say the t-test, another name for this t-test is independent samples t-test. So this is used in t-test, or you can say, or independent samples t-test. So you should know all the names. There's one more name, or students t-test. Students t-test. These are the three names, and any name. Normally, the most popular names are t-test and independent samples t-test. Please see, don't write sample. It has to be samples. So this is what the concept of degree of freedom. And now the question which normally people ask is, I'm writing the question, can degree of freedom value be in fraction mathematically? Can the degree of fraction, can the degree of fraction be in fraction? Can degree of freedom, I'm sorry, can degree of freedom be in fraction mathematically? Just think about it. And I'm sure you will be able to say the answer is yes, it can be in fraction mathematically. The another question is, can df be in fraction conceptually, can you say that can the DF value be in fraction? The answer is no. Why? Because the DF is your number of observations, and number of observations can never be in fraction. It has to be always in the whole number, because N1 means number of observations, or it is a frequency. So the frequency means what? The occurrence of event. Now, if there are 300 participants in this particular webinar, then what is the value of N? It is 300. That's what the meaning of the occurrence of event. So therefore, conceptually, your degree of freedom will always be in the whole number, but mathematically it can be in fraction. And I do not know how many of you have ever got this information that degree of freedom can be in fraction. The book, if any one of you is interested in reading, it is Business Statistics by Ken Black. This is one book which you can read, and this information is given here. All those people who read Statistics for Education and Psychology by Garrett, this book does not give this information. If you read Statistics book by Guilford, the book does not give this information. So please understand, it is important for all of you to read books belonging to different subjects. And the more widely you read the books on research methodology and statistics, the more richer you will be, because you will get that type of information which maybe the people do not know. Okay, this is one book which you can see. Another book is Business Statistics for Management and Economics by Anderson et al. These are the two books which give this particular information. The book Business Statistics by Ken Black gives another information, and that information is when the sample size is less than 30, why it is called a small sample. I repeat, when the sample size is less than 30, why is it called a small sample? And when the sample size is either equal to 30 or more than 30, why do we call it large sample? Now, such type of informations you will find in a book which is Business Statistics by Ken Black. Okay, now the degree of freedom can be in fraction, and what exactly will be the formula? If you like, I can give you the formula. So if you want, you just tell me, I will tell you the formula. Absolutely no problem in that. Okay. And if I don't get any hint from your side, I will not give you the formula. Formula is available in Business Statistics by Ken Black. Okay, we proceed further. So I have completed one concept, and that is the degree of freedom. The another concept which now I am going to tell you is level of significance. Level of significance is the point on which I am right now at present, and now I tell you what it is.
Excuse me, sir.
Yes.
Sir, they want the formula, they're saying.
Okay, you want the formula, so I am giving you the formula.
Yes, yes, please.
The formula is something like this. DF equals, and if I denote the standard deviation by S, if I say S is the standard deviation, okay, so I just, all right, I can write here, no problem. If S is the standard deviation, and this is a small s, you should consider. So the formula is S1 square, S1 square, okay, divided by N1 S1 square divided by N1, then plus S2 square, okay, divided by N2, and this is the whole square. So S1 square upon N1 plus S2 square upon N2. S1 means standard deviation of the first group divided by N1, the number of the members in that particular group, plus S2 means standard deviation of the second group square divided by N2, the total number of members. I hope you are understanding. And this whole is divided by, now I am just trying to copy, and let us say, hope it will work. This, that S1 square upon N1, okay, minus 1. And this, the whole square. Okay, and then it is minus, no, not minus 1. This whole square divided by N1. Okay, divided by N1, I can put it here. Okay, divided by N1. And then it is minus S2 now I am So this is S2 square divided by N2, okay, then minus 1, this whole square. This whole square, and then it is divided by N2. This is the formula which you have to use if you want to find out the degree of freedom when your homogeneity of variance is not used. Just now I will tell you, but this is the formula. If you use, then your degree of freedom will be in fraction. And when do we use this formula? We use this formula that if you are using, let us say, t-test. If you use the t-test, and when you are using the t-test, then there are assumptions. The one assumption is normal distribution. Normal distribution of the criterion variable if it is a survey research, or normal distribution of the dependent variable if it is an experimental study. That variable must have a normal distribution in the population. And the second is assumption is homogeneity of variance. Okay, so these are the two. If these conditions are fulfilled, and the third is the scale of measurement must be either interval or ratio scale. If these conditions are satisfied, then my degree of freedom will be equal to my degree of freedom. The formula is N1, the one which I gave you just now, N1 plus N2 minus 2. This is the formula which you should use. And the statistics for education and psychology by Garrett has given only this formula. That book does not talk about the degree of freedom which is in fraction. So if this condition is satisfied, these three, then this is the formula you can use. But if you don't have this, but if the assumptions are, now I'm changing the assumptions. I'm just copying and paste so that I don't type it again. So suppose the assumptions are, number one, normal distribution, homogeneity of variance is not satisfied. Okay, so that means whatever are the differences in one group, the same magnitude differences do not exist in the second group. And when that happens, it means the homogeneity of variance is not satisfied. If that condition is not satisfied, but the scale of measurement is interval or ratio, then you cannot use this particular formula to determine the degree of freedom. Then the formula which you have to use is the one which I gave you here. So this is the formula which you have to use in order to calculate the degree of freedom. So this is the formula which you have to use. And this is only and only to be used when the homogeneity of variance condition is not satisfied. And right now, I will be taking one objective, a hypothesis, and then I will test that hypothesis and will tell you how exactly this has to be done. Nothing to worry about it. All right, I go to the next concept and is level of significance. Now, I'm sure you know that when you were a student and when the exam used to be there, then when you used to see your result, you might have observed that some students failed and some students passed. So that means there is one fine line between the pass and the fail. Those people who failed, they did not get marks up to a particular limit. If the passing percentage is, let us say, 40%, then those students who did not get 40%, they were placed in the fail. And those who got 40 and above, they were placed as pass. So there is a fine line. Okay. Now, another thing I'll tell you. Suppose if you are traveling by bus and the bus is full and someone hit you, and if someone hit you, you ask him, why are you hitting me? And the person may say, sorry. Why did he say sorry? He said sorry just to convey that he did not hit you intentionally, but it was unintentionally. That means it was by chance. So that means the event that will occur, either it occurs by chance or it does not occur by chance. For example, during the raining season, when it rains, then we do not say that by chance it rained. But when it is off season and when it rains, then we say, oh, by chance today it rained. Why by chance? Because that is not expected. So that means there is a fine line which discriminates between the occurrence of event by chance. Okay, and I'll say occurrence of event by chance, and another is the occurrence of event not by chance. Another is occurrence of event not by chance. Not by chance. And when you say it is by chance I hit you, by chance. See, many a times you say, when you are walking on the road or you are in the market, and sometime you come across your friend. No, it was not intentionally you met him. It was not pre-decided. It was unintentional. By chance, he came to the market at that point of time, and you also happened to be there at that point of time. And when you come back home, you do share with your family members that today, by chance, I met such and such person in the market. Oh, you met him? Yes, how are the people? And then you say, everyone is fine. That's fine, okay? That's what exactly the meaning of that. So when we say it is occurrence of event by chance, that means there are some error. See, there is two words. One is a mistake and another is error. When it is a mistake, it can be rectified because you can find out, and once you find out the mistake, then you can rectify it. But in case of error, you are unable to know, and therefore you cannot rectify it. I'll give you an example. Chandrayaan-2 was launched, and you know that Chandrayaan-2 in the first, when they started launching, at that time there was some problem, so they discontinued the first launch. The second time when it was launched, it did not land at the designated point. It landed 4.2 or some kilometers before that particular point. Why Chandrayaan-2 could not land at the designated point? The scientists started analyzing, and then they might have come to know that there was some error. So please understand, whatever you do, error is an inbuilt part of it. Let me give an example. When you take your lunch or dinner, before that you wash your hand. Now, after washing your hand, if you take your hand under the microscope, you will find there are some germs, and you eat with that hand. So that means you are eating with dirty hand. But the degree of dirt is such that you are able to tolerate it. So therefore, this error is also called level of tolerance. You know, when someone abuses you, you ignore. But if he still continue to abuse you, then after a particular point, then you start giving him back. Why? Because it has crossed your level of tolerance. Okay, so this level of significance is also called level of tolerance. And when you tolerate good things or you tolerate bad things. I'm sure you will say you will tolerate bad things. Good things we enjoy. Okay, so level of significance is another name is level of tolerance. And what do you tolerate? That whatever you do, there will be some error. Okay, and that is important. So there is a fine line which discriminates between the occurrence of event by chance and not by chance is called the level of significance. I repeat, you can note it down. I start. The fine line which discriminates between the occurrence of event by chance and not by chance is called level of significance. So it's a very, very fine line, you know, between the two districts. There is always a fine line that up to that particular point, the land of that district will end and the land of another district will start. You know, there is a LOC, line of control between the two countries. And you know that India knows that our land is only up to this place. It is sharing boundary with many countries. So there is always that fine line. There is a fine line which discriminates between pass and fail. There is a fine line which discriminates between first division and second division. Well, like this. Okay. So that means that's what is the concept of the level of significance. Now I proceed further. Suppose you repeat one research 100 times and you get 99 times same result. But, and not 99 times, I'm taking, and 95 times the same result, but 5 times you did not get the same result. Suppose you repeat one research 100 times without deliberately changing anything. And if you get 95 times the same result, but 5 times the result may differ. Why the result is different? The result differs 5 times means there might have been some error, not mistake, error. Okay, so when you repeat one experiment or one research 100 times, and if you have 95 times the same result, but 5 times your result is very different, then you can say you are 95% confident that this result will come. But if I talk the level of significance, then level of significance is equal to you have 5% because out of 100, 5 times you are not getting the same result. So that means it is 5% error. And the 5% error means it is 5 divided by 100. And 5 divided by 100 means what? 0.05. So your level of significance becomes 0.05. And when you say your level of significance is 0.05, that means the percentage of error is 5%. Okay. And if you want to talk in terms of the confidence, then you say I'm 95% confident that this result will come. That is the meaning of 0.05 level of significance. Now, suppose now I am giving you another concept. Suppose you repeat one research 100 times and 99 times you get the same result. But once you do not get the same result, that means what is the error? The error is 1%. And when 1% is divided by 100, then the level of significance becomes 0.01. So level of significance, when it is 0.05, the meaning is error is 5%. And when the level of significance is 0.01, that means 0.01, that means it is 99% you are confident. And when it is 0.05, 95% you are confident. Now you can think, I'm giving you one question, which of the following level of significance is the highest? Now, which of the following level of significance is the highest? Now I am giving you 0.58. This is A. Okay, I can put A. No problem. Okay. The another is 0.08. Okay, I can put 0.08. All right. Another is 0.05. All right. Another, okay, 0.05. All right. Another is 0.01 and another is 0.009 and another is 0.23. Now of these, which level of significance is the highest? Think about it, and if you want to tell me, you can tell. Okay, now that is what is the concept of the level of significance. Now, dear friends, you must be knowing that when you go to the doctor and when doctor examines your blood count, and when the pathology people, they give you the report, they give your blood count, and along with that, they will say the normal blood count must be this. Now, if that normal is not given, then the doctor will not be able to say whether your blood count is all right, or it is more, or it is less. So there must be some standard value so that you can compare and you can find out whether you are suffering from this or you are not suffering from this. Say temperature, you know the body temperature. There is a one body temperature which is normal. If your temperature is more than that normal, then you say you are running a temperature or you are having a fever. If it is not, then okay, fine, that you are all right. So there are some standard, and there are large number of standard values in medical sciences, in pure sciences. Now the statisticians also have given us the standard values. So what we have to do is, whenever we calculate a value, then we have to compare it with the standard value. And after comparing it with the standard value, then we can find out whether it is normal, it is not normal, how much error it has or how much error it doesn't have. Now those standard tables are there. I have the standard tables. So I will just like to share with you and will now tell you, this is the standard table. You must have seen this is the standard table of t-value. Like this, there are standard tables of f, there are standard tables of chi-square, there are standard tables of correlation, and so on and so forth. Now, how do I use this particular one? I will just like to tell you, and then maybe I will explain you one more, the concept. And then I will go to my SPSS so that I take the data and I will tell you this is what is called the testing of the hypothesis. So let me first give you one more information and then we proceed further. I hope all of you are able to see this particular table. Okay, say this is my table. Now, suppose my degree of freedom, you know here that this is what is my degree of freedom, and degree of freedoms are in whole number. Okay, and this is my level of significance where error is to 20%, here error is 10%, here error is 5%, here error is 2.5%, and here error is 1%. Okay, so suppose I have my DF. If I say, suppose my DF is equal to 29. My DF is equal to 29. I'm just making it bold. Okay. When DF is equal to 29 and the t value which I have calculated, this is equal to, let us say, 1.70. Okay, I repeat, my DF is equal to 29 and the t value which I have calculated is 1.70. Now I have to find out whether this particular value is significant or not. Do you people know the rule which you have to use? If you know the rule, then I need not to tell you. But if you do not know, Bobby, help me. Should I tell you the rule or there is no need?
Yes, sir. You may, sir.
I can give.
Yes, yes.
All right. Okay.
Yes.
So the rule is, please see, if you see this value, this your DF is 29 and the value given under 0.05 is 2.045. And this my calculated value is 1.70. And this 1.70 is less than the table value given under 0.05 level, and that is 2.045. So that means this particular value is not significant. Why? Because it has got the more error. So what is the rule? The rule is, I'll tell you the rule. The rule one is that for the given DF, if the calculated value is less than the table value given under 0.05 level, then the calculated value is not significant. Please understand, this is my rule number one. Why it is not significant? Because the error is more than 5%. When you move on the left hand side, the errors are increasing. And when you move on the right hand side, the errors are decreasing. So this for DF is equal to 29 and my T value is equal to 1.70. It falls on the left hand side. So the error is more than 5. So therefore this is not significant. So I hope you have understood it. Now rule number 2. The rule number 2 is for the given DF, if the calculated value is either equal to or greater than the table value given under 0.05 level, but less than the table value given under 0.01 level, then the calculated value is significant at 0.05 level. Hope it is clear to you. So whenever your calculated value is either equal to or greater than the table value given under 0.05 level, but less than the table value given under 0.01 level, then the calculated value is said to be significant at 0.05 level. The rule number 3. So this was my rule number 2 and this was my rule number 1. Now I am giving you the third rule. I am copying and pasting and just making changes. Okay. Rule number 3 is for the given DF, if the calculated value is either equal to or greater than the table value given under 0.01 level, then 0.1 level, then the calculated value is significant at 0.01 level. I repeat, this is rule number 3. For the given DF, if the calculated value is either equal to or greater than the table value given under 0.01 level, then the calculated value is significant at 0.01 level. I hope you have understood these 3 rules. Now I use these 3 rules and just tell you now, if you see this particular thing, when DF is 29, this is my DF, it is 29, and the value given under 0.05 is 2.045, and this value is less than, that is means it is not significant. Okay, and I am just writing for your benefit. Otherwise, whenever it is not significant, we should not mention the level, because our lowest level is 0.05, where error is the highest, the 5% error. Okay, so it is not significant. I'm just saying at 0.05 level. And when it is not significant, what is the meaning? The meaning is that means do not differ significantly. And when the means do not differ significantly, then my null hypothesis is not rejected. Please understand. Then my null hypothesis is not rejected. Why? Because whatever the value that you have, it has more error. So that is why you are not rejecting your hypothesis. Now you cannot say that you accept the null hypothesis, because in some of the books it is given that null hypothesis is accepted. You cannot write the word accepted, because when you conduct a research, you do not collect data from all members of the population. I repeat, you cannot say accepted word because you have not collected data from all members of the population. You have collected data from the sample belonging to the population. And you know, in social sciences, the sample really does not truly represent the population. So in your case, it is not rejected. In somebody else's case, it may be rejected. Please understand, this is important information I am giving you. Okay, so null hypothesis is not rejected. This is the true situation. But if you just see here, that if you see this value at a lower level, the DF 29, and my lower level is 0.10, and the value given here is 1.699, and this value is 1.70. So that means this t-value, it is significant at 0.10. It is significant at 0.10 level. What is the meaning? The meaning is that means differ significantly. And when means differ significantly, then what do? Then you say null hypothesis is rejected. Please understand, it is the same value. I'm not changing the t-value. I'm not changing the degree of freedom. What have I done? I have only changed the level of significance. That instead of having 0.05, now I am having 0.10. That means error is more. So understand that in reality, your null hypothesis should not be rejected, but as a researcher, your decides to reject it is called type 1 error. So I repeat, in reality, the null hypothesis should not be rejected, but researcher decides to reject it is called type 1 error, or it is called alpha error. So I hope you have understood that in reality, your null hypothesis should not be rejected, but the researcher decides to reject it. This is called type 1 error, or it is also called alpha error. I hope you have understood it. Let me take another example. Now I am again moving up. Suppose my another example I am taking is that, let us say, suppose my DF is equal to let us say 40. If DF is equal to 40 and my suppose the calculated t value is 2.021. Now, please see this. When DF is equal to 40, this is 40, and my calculated t value is equal to 2.021 in 40. The value at 0.05, it is 2.021. So my calculated value is equal to the table value. So that means it is significant. It is significant at 0.05 level. Now, when it is significant, what is the meaning? The meaning is the means differ significantly. The meaning is means differ significantly. And when means differ significantly, then your null hypothesis Okay, then your null hypothesis is rejected. Why? Because it says that means differ, and your null hypothesis says means do not differ significantly, but it says means differ significantly. So then null hypothesis is rejected. Now, if you consider this value at a higher level, when df is equal to 40, you consider this value at 0.01 level. At 0.01 level, the value given is 2.704. When df is equal to 40, the table value given at 0.01 level is 2.704. And this value is less than this. Then you'll say it is not significant at 0.01 level. Because at higher level, it is not significant. And if it is not significant, then you say means do not differ significantly. And when means do not differ significantly, then you say null hypothesis is not rejected. Please understand. That in reality, the null hypothesis should be rejected, but researcher decides not to reject it, is called type 2 error, or it is called beta error. Hope you are understanding. So therefore, I write, in reality, the null hypothesis should be rejected, but the researcher decides not to reject it, is called type 2 error or beta error. So this is what is actually the type 1 error and the type 2 error. And dear friends, whatever you do, whenever you have any level of significance, that means there is some amount of error. It is impossible to have a research without error. Any subject you have. In science also you have errors, in social science, humanity, everywhere you have errors. But the type 1 error is more dangerous than the type 2 error. Why? Because type 1 error means any value you calculate, that value will be significant at some level. That may be 0.98, that may be 0.99, that means 99% error. Yes, it may be significant. So that is why type 2 error is type 1 error is more dangerous than the type 2 error. because in the type 2 error, you are limiting the 5% and you are going on the higher side. That means the value is significant at 0.05. And now I give the last statement in respect of type 1 error and type 2 error. Whenever the value is significant at 0.05 level, then it indicates that it is not significant at 0.01 level. But when you are writing, then you should only write that the value is significant at 0.05 level with DF equal to this. That's all. You should not write that the value is significant at 0.05 level, but not at 0.01 level. This is incorrect statement. Technically incorrect. You cannot write like that. Second statement, whenever your value is significant at 0.01 level, then you should not write that the value is significant at 0.05 level as well as at 0.01 level. This is incorrect statement. In place of this, you just write that the value is significant at 0.01 level. Whenever the value is significant at a higher level, it has to be significant at a lower level. So there is no sense of writing that it is significant at 0.5 level as well as at 0.01 level. No, you need not to do that. So I have covered type 1. Okay, now I'm going to the test. And for testing of the hypothesis, now I'm going to take one objective, and let me now take the objective. Suppose my objective is to compare mean scores of reasoning of male and female students. Suppose this is the one, then what is my hypothesis? My hypothesis will be that there is no significant difference in mean scores of reasoning of male and female students. So that's what is the one. If this is what is known as my hypothesis and this is my objective, then let me now go to the SPSS. I'm sure some of you might be knowing the SPSS. So this is my SPSS. I'm sharing the screen. Are you able to see this screen, Bobby, madam?
Not yet, sir.
No, this is the screen, which is the SPSS screen.
It is not visible, sir.
I think it should be visible. It cannot happen. But this is visible.
No, just a blank.
No. There is no blank. This is the same one, the Word file Are you able to see the word file?
Yes, yes, exactly, sir.
You are able to see. So therefore, now I am sharing with you another file. Are you able to see this is the blank file?
Yes.
Okay, all right. Now please see. This is what is SPSS file.
Okay.
And here VAR is written. VAR means variable. So in one column, you have to put the value of only one variable. So if you have 10 variables, then you must use the 10 columns for one column for one variable. So if you have 10 variables, so you must have 10 columns. Now, right at the moment, if you know my objective, in this objective, you can say that in this objective, you say that there are two variable. One is the reasoning and another is a gender, because I have the
Bala,
male and female. Okay, and male and female is a discrete variable. So therefore, reasoning is a continuous variable. So now I am defining, go to variable view. Here I say gender. And gender has got two levels. So I'm putting two. I'm defining. One means if I say male, you can write anything you like, doesn't make a difference. These are codes. Two means female. So whenever I enter the data of the male, I have to write 1. And when I enter the data of female, I write 2. Okay. Now the next one is reasoning. And reasoning is a continuous variable, so no problem at all. Now we have to define our variable. Now I go to the data view and you can find both these variables are here. So I can take the sheet of the first person, and if first person is female, that means I will type 2. I have entered 2. If the
Sir, the participants are
Dr.
not the,
Dayanand?
right. Ravi, sir, say. The
Dr.
participants,
Dayanand, we are unable to see the screen actually, sir.
you are not able to see the screen. But are you able to see?
Yes, sir.
Bobby?
It's blank now.
Bobby, are you able to see?
I was able to see, sir, but then like again it became blank.
Oh my God. Okay. All right. Let me share and is it all right?
It is visible, sir.
Are you able to see it?
Right, sir. Right, sir.
All right. So participants are able to see?
Yes, yes, sir.
All right. So,
Yes, sir. It is visible. Thank you, sir.
all right. Welcome. So the first of all, what I did was I went to the variable view, and here I had entered the name of the two variables. One variable was gender, another variable is reasoning. So gender was a discontinuous variable. It has two labels. So I put the labels, and here I gave code. One is not a weight, it is a code. Your roll number in the examination is a code. Your mobile number is a code. Your car number is a code. Your house number is a code, and so forth. Your Aadhaar number is a code. All these are codes. So you can put anything you like. And then second is reasoning, which is a continuous variable. After defining, I go to the data view. Now I can enter the data that first person is female, and if my maximum score is 40, I say she got 25. Another is again female, and suppose she got 32. And another is a male, then I say he got, say, 22. So like this, I can enter my data, or I can first enter the data of all the gender. Let me enter the data of all the gender. I'm just entering the data. I am first entry whether they are male or female. Suppose I have entered this much, I will not enter much. Now I enter their reasoning scores. So I can move from bottom to top, or if you like, I can go to the top, no problem at all. I can start from here and I can go down. So next is the male, I find out what is the number, say this, the female is 27, say another is 29, say here is 22, say here is 17, here is 26, say 21, say, okay, say 26, say 23, say 12, say 18, say 27, say 15, and say 26, say 22, and say 27, and say 19, and say 20, say 22, say 28, say 18, 26, say 20. I'm just entering the data randomly. I'm not in a particular one, okay? I have entered the data. Now I go to analyze. And because I want to compare means, so I go to the means. And here I have two independent group. So I say independent samples t-test. So I click here and I get a dialog box like this. Here on the right hand side column, here test variable is written. So here you have to enter that variable whose mean you want to compute. So I want to compute the mean of reasoning, so I shift it here. Now it is a grouping variable. The grouping variable means it is a variable which is discrete variable, or it is a variable on the basis of which you have divided the students into groups. And I have divided on the basis of gender. So I will shift gender here. And then I define gender. I have said 1 and 2. If you want, you can say 2 and 1. Either you can compare the mean scores of reasoning of boys with the mean scores of reasoning of girls. Or you can compare the mean scores of reasoning of girls with the mean scores of reasoning of boys. It's one of the same thing. It doesn't make much difference. Okay. And I will do and tell you the result is same. All right, I continue. Now in the option, it is confidence is 95% confidence, because maximum allowed error is 5%. So therefore your confidence may be 95%, not below 95%. Okay, so I don't want to change it. I continue. And this is what is I have got the values. Okay, now all of you are requested to note down these values because I will be using these values in order to test my hypothesis. So I'm writing. Now I'm writing my male, the N is 17 and the mean is 19.82 and the standard deviation is 3.76. Either I can take standard deviation or I can take standard error. It does not make a difference. So I'm taking standard deviation. Now, in case of females, there were 19 females and the mean score of reasoning is 25.84 and standard deviation is 2.986. So it is 2.99. Okay. And now you see here, there are two t values. One is equal variances assumed and equal variances not assumed. Now, how to decide whether I should use this equal variances assumed value of the t, or I should use the equal variances not assumed value of the t? It depends upon, this is the Leven's test for equality of variances. Now here, this is my f value and this is my significance. It is 0.264. If I multiply it by 100, it comes to 26.4% error. And the error cannot be more than 5%. So the meaning is this, my f value is not significant. And if this f value is not significant, the meaning is whatever are the differences in respect of reasoning in the male group and in respect of reasoning in the female group, the differences are of the same magnitude. And when differences are of the same magnitude, then my equal variances assumed condition is satisfied. Okay, and then I should take the t value, which is the upper one. And here it is minus because 19.8 minus 25.84. That is why it has come minus. I will take first female and then male, and then you can find it out, no problem at all. And now here the degree of freedom is 34 and you see the level of significance is 0.01. Why? Because here it is 0.000. Whenever you have 0.000, then it makes it is significant at 0.01 level. Now let me just once again do it by changing. Now I'm just changing the gender that I take to, I'm taking first and then I'm taking 1. And then now you can see again here, the t value now is positive. So it does not, and value is the same. It is 5.344. In earlier case also, it is 5.344. So whenever you get a negative t value, never write negative, because t indicates the difference and difference is always positive. Difference is never negative. Those of you who belong to science, then the difference is a scalar quantity. which only have a magnitude but not having the direction. If it is a vector quantity, it has both the direction as well as the magnitude. Now, these value I have to take, and now let me test my hypothesis. So I'm now going to share with you again this file. Now I'm going to share this file. Are you able to see this file now, madam?
Yes, yes, sir.
Thank you very much. All right. Now, this was my objective. And from the objective, can you tell me what is the heading that I should write here? I think you can tell me. The heading should be gender-wise comparison, gender-wise comparison of mean scores of reasoning of students. Now this is the heading which will come up from the objective. You cannot write at your own. It must be taken out from the objective. And then you say the first objective was to compare mean scores of reasoning Oh my God. Is it okay? Are you able to see this, madam?
Yes, sir. Yes, sir.
So this is my first objective. The first objective was to compare mean scores of reasoning of male and female students. The data were, I have to write in the past tense because we have already analyzed the data and we are now reporting it. So data were analyzed with the help of I can write t-test, or I can write independent sample t-test, whatever you like, are analyzed with the help of t-test, and the results are given in table 1. So now I have a table and I can insert the table 1 here. And so I'm going here and insert my table. I'm inserting and I'm saying auto fit. So the first is my gender, and the second will be my mean, next will be my standard deviation, and next will be n, and next will be my t-value. So here I know my male. Okay, I'm just taking it down. So male, and then I say female. Now the mean of the male is 19.82 and that of the female is 25.84. The standard deviation for male is 3.76 and standard deviation for female is 2.99, and males are 17 and females are 19. and my t value is 5.34. Now this t value is significant. So I can do two things. I can put the double star here, and below this, I can put double star and say significant at 0.01 level. If you want to represent like this, you can represent. The convention is if you are putting double star, that means the value is significant at 0.01 level. If you are putting single star, then means the value is significant at 0.05 level. Now here it is significant at 0.01 level, so I have put a double star. If you do not want star, then you can take it out, and you can take out this also. And here you can add one more column. So I can insert the column, and here I say remark. And here I'll say the P is less than 0.01. P means the probability, and this must be small. Okay, the level of significance is represented in terms of a probability. So P. So this is how you enter your data, and now you have to write the heading. The heading is gender wise mean SD and T values. Why values? Because it is mean value, it is SD value, it is N value, and it is T value. Mean values of reasoning of students. This is the table heading you have to write. Now I start writing from table 1. It can be seen that the T value is 5.34. Please do not write that the calculated T value, because whatever value you have entered in the table, it is a calculated value. So no need of writing calculated value. I have seen many researchers, they write the calculated value, so that is technically wrong. Value is this, which is significant at 0.01 level with DF equal to 34. This is the first sentence which we should write here. Why 34? 17 plus 19 is 36, minus 2 is 34. Now we should say it indicates that there is significant difference in mean scores of reasoning of male and female students. When your T value is significant, that means the mean scores of reasoning of males and females differ significantly. And once they differ significantly, thus the null hypothesis that there is no significant difference in mean scores of reasoning of male and female students is rejected. Now, once I write is rejected, now my hypothesis has been tested. So this is what exactly is called testing of a hypothesis. So testing of a hypothesis is part and parcel of your interpretation. Without collecting the data, without analyzing the data, you cannot test your hypothesis. This is very important. Now, this is what refers to the testing of a hypothesis. But your interpretation has to keep on going. It is not over. Further, the mean score of reasoning of female students is 25.84, which is significantly higher than those of male students whose mean score of reasoning is 19.82. This is important. You should write that. It may therefore be said that female students were found to have significantly higher or better reasoning ability as compared to male students. So dear friends, once you have this red one, this is your finding. So I hope you have understood. So this is your finding, but once you write something like this, this is your testing of hypothesis. So I have completed the testing of a hypothesis, and just if you give me 5 minutes, I can just tell you the 2-tailed test and 1-tailed test if you are interested. If you are not interested, then do not bother about it. Over to Bobby, madam.
Sir, they are interested, sir.
Okay.
Participants. Okay.
Then I'm take just 2 minutes.
Right, sir. Right, sir.
Okay. Now please see this one. This is a normal probability curve. You might have seen it. And there are 2 tails. One is on the right hand side, which is dark blue color. Another is on the left hand side, which is again dark blue color. And this particular curve never touch your x-axis. It never touches. It's always above. because it cannot cover everything. Okay. Now, when you are having a level of significance, say 0.05, this is error, 5% error. Now you divide this error on both sides of the tail. And when you divide this error on the both sides of the tail, then you are in reality using the two-tailed test. What is the meaning? The meaning is the standard values, the table standard values for two-tailed test. Okay. And now the formula for computing T remains same. It is only the standard values. These are the standard values. You see, this is two-tailed. Here is a two-tailed. I'm sure you are able to see it. And this is your one-tailed. So if it is your 0.05 in the two-tailed, then this is what you should see it. Okay. And these are the values then you should see for 0.015. Now, but if your complete error is on one side of the tail, either on the left-hand side of the tail or on the right-hand side of the tail, then now you can say your level of significance is 0.05. Now, I just move it here. If my value is here, please see this where you can see my cursor. If the value is here, then this value is significant in case of two-tailed. Okay. But if the value is here, this value is not significant in case of a two-tailed. But if you see this value exactly here, this is here and it is here. Now in the one-tailed test, the value will become significant. So when you see the values for the two-tailed test, the table values are higher for the two-tailed test because the error is equally divided on both the sides. But in the one-tailed test, the whole error is on the one side of the tail, and therefore the table values decreases because the error increases. So you go back to this standard table. Now this is the standard table. When DF is equal to 6, the value for the one-tail test under 0.05 is 1.943. But if you want to see it for the two-tail test, then this value is 2.447. So if I say that when DF is equal to 5, and if my calculated value is 2.015, DF is 5 and calculated value is 2.015. Now this value is significant at 0.05 for the one-tail test. It is significant at 0.05 level in the one-tail test. But this value is not significant in the two-tail test. So it is not significant. Please understand. So when you see the one-tail test, then you have to test your directional hypothesis. Okay. And the directional hypothesis, and when you have a null form of the hypothesis, then you have to see the values for the two-tail test. Now, in this particular case, the interpretation just now I gave you, this interpretation which I gave you now here. You see, my null hypothesis is rejected. And if it is a directional hypothesis, then directional hypothesis should not be rejected. Okay, because it falls in this particular one. It in the one tail test, this value and here. So therefore, when my null hypothesis is rejected, then my directional hypothesis is not rejected. But when my null hypothesis is not rejected, then my directional hypothesis should be rejected. So this is on the basis of one tail test and two tail test. And most of the time, researchers formulate hypothesis in the null form because they do not have strong evidences, and that is why we always use two-tailed test. But if you want to use one-tailed test, you can use. You have to be careful when you are writing your interpretation. So thank you very much, and sorry that I have taken more time. So please, over to you, organizers.
Thank you so much, sir. It was really a wonderful session. In fact, this webinar has partially taken the shape of a workshop, which is very important for the research scholars as well as the people who are associated with research publications. So now, Shiva Shakti, madam.
Yes, ma'am.
Should we just open up for participant to raise
ma'am.
questions?
Already I added, ma'am.
Right. So participants, could you please unmute yourself and ask question?
Yeah.
Go ahead.
Thank you, sir, for this wonderful session. And I attended several sessions, but still I have one doubt that is actually not my doubt. I cannot explain what is the importance of a null hypothesis in statistics. I can understand that we cannot test all the individuals of a population, so we have to use this null hypothesis. That's the idea for me, but I cannot explain this concept to my students. I request you to give me a funny or good example to elaborate such an idea to my students.
Let me tell you, all these statistical techniques were developed by statisticians. And when they developed this particular technique, they had a model. And the model which they have taken was a null hypothesis they had taken, that there is no significant difference. That was the basis. So each and every statistical technique can test your null form of the hypothesis directly, but they do not test directly the other. And this is because the assumption in developing these tests was null hypothesis. That is the reason that why we always say the null. Another is because when you are formulating your hypothesis, it is not your choice. You have to have a base. And one of the base, yesterday I told you, review of related literature.
Okay.
Because from the review of related literature, if you are not having strong evidences to point to a direction, then you cannot formulate hypothesis in the direction form. You have to have a null form. So these are the two reasons which you can tell to the people and still if they do not understand, do not agree, nothing can be done. Next question.
Thank you, sir.
Welcome. Next question.
Yes, sir. Yes, sir. In your really, it is an informative session and informative representation. But you did not, sir. You did not mention anything about positive and negative hypothesis.
My dear friend, it is
Isn't there any negative or positive hypothesis in writing the research or statistical analysis?
No, please, it is a misnomer. There is nothing like positive hypothesis, and this is nothing like a negative hypothesis. This is a wrong information which people give. There is no hypothesis called positive hypothesis or negative hypothesis. Hypothesis can be either in the null form or can be in the directional form. So this is a wrong information which people give. Thank you very much.
Okay, thank you.
Hello, sir. Can I ask one question? So, sir, your lecture is very fruitful and you described so many aspects.
Dr. Hemlata ma'am, your voice
When
is
we
break.
are using
Breaking,
the test, because we don't know the standard deviation of the population,
Hemlata madam.
it affect the shape of the graph in the
Hemlata madam.
T distribution. So as the degree of get larger, the area in the tails of the distribution gets smaller.
No,
And as of approach infinity, the
madam, your voice is
will
not
be
clear.
look like a normal distribution.
Ma'am, Hemalata ma'am, your voice is
Yeah.
breaking. Your voice is breaking.
Oh, so
Not clear.
now
It is echoing, ma'am. Echoing. Maybe a speaker is on or something like that.
yes. Because I was trying on the phone.
Right.
So I am. It is okay, no? No.
No, ma'am.
Now?
Yes.
Yes,
Yes,
ma'am.
it
Okay,
is
ma'am. Okay, ma'am.
Sorry? We are using the t-test because of we don't know the standard again.
No, madam, I'm not able to get you. Your voice is breaking.
Oh, sorry, sir. Now it is all right. Okay?
Echo is.
Can I off the phone?
Yes, ma'am.
Shiv Shakti, madam.
Yes, sir.
You can hear and then you can.
Ma'am,
Sir,
switch
I
off
am
your phone.
that we are using the t-test because we don't know the standard deviation of the population.
No, madam.
Ma'am,
No.
please type and send the chat box, ma'am. Please, ma'am.
Yes, Dr. Hemlata.
It is all right.
Okay.
Ma'am, use two mobile, no?
Yes.
Please off the one system, please, ma'am. That's the problem. Yeah.
Okay.
It's better, ma'am.
Okay, it is better. Sir, we are
No, ma'am.
now not possible.
Ma'am, please mute one system. Mute one system or phone.
It's good. It is okay. What happened? Sir,
Dr. Bobby, ma'am. She used
then
two
you are
mobiles.
not
Dr.
possible.
Bobby, ma'am. Dr. Bobby, ma'am.
Yeah, yeah.
She used two mobiles or one mobile and system.
Okay, I'll, Hemlata madam,
Yes,
Hemlata,
yes, yes.
you're using two headsets, I think two system.
Mobile and please switch off one mobile or laptop.
Either you have to mute it.
Mute, mute.
Mute it.
It is okay?
Okay, okay.
Yes.
You are hearing me?
Yes,
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 madam.
yes.
Yes,
Now,
we hear
now,
you.
okay.
Yes, we hear
Okay,
you.
Yes.
okay, okay.
So,
We hear you.
I'm telling that we are using the t-test because we don't know the standard deviation of the population. The degree of freedom affect the shape of the graph in the t-distribution. As the degree of freedom get larger, the area in the tails of the distribution get smaller. And as degree of freedom approach infinity, the t-distribution will look like a normal distribution. So when this happens, what will be the effect of our standard deviation? Sir, what is your opinion in this regard? Sorry.
No problem. Are you able to hear me, Hemlata madam?
Yes, yes, yes.
Now,
I am hearing you.
Your question it needs little correction. Standard deviation is never of the population. Standard deviation is only of the sample. You can never collect data from all members of the population. And that is why from the standard deviation, we estimate the standard error. So standard error is estimated. It is never calculated because standard error indicates the differences, the differences amongst the samples. So therefore, what you are thinking is slightly, you have to change your thinking. So that is the answer.
Okay, thank you. Thank you, sir.
Next question. Thank you, madam. So nice of you.
Okay, thank you.
Next question, Bobby, madam.
Any other participant, please? Please unmute yourself and ask question. Sir, otherwise you can just have a look at the question and answer box, sir. There are a few questions out there.
If you can read, then you can read and you can tell me, I will answer.
All right. There is one question. They want an example of exploratory survey and one of the descriptive survey. An example.
Say, whenever, example, exploratory survey, whenever a businessman, he wants to establish a industry. If he wants the industry, then he does the exploratory survey. The geology people, they do the exploratory survey. Okay, that is the example of the exploratory survey. And descriptive survey is nothing but whenever you want to describe any tribe. So therefore, and when you want to describe any tribe, then you have to be along with those tribe, and ethnography researches are always of the descriptive one. So these are the two examples I gave earlier also, and now also I'm saying. What is the other question at your end? Does a questionnaire or scale? There was some question coming here.
No more questions, sir.
There is one question. Kindly throw some light on data analysis with regard to qualitative data.
Which analysis?
Data analysis, like qualitative data, qualitative, not quantitative.
When you have the qualitative data, the analysis which you can do, number one is a content analysis technique you can analyze. Another is a meta analysis you can do. And third one is a SWOT analysis which you can do. These are the different techniques available that you can do it. Question?
Another question with regard to the concept of equality of variance. A little bit of explanation they, like participants are asking.
The equality of variances means whatever are the differences in the one group, in another group also the differences are of the same magnitude. And when that happens, that is what is called homogeneity of variances. That's the meaning. That means the differences within the groups do not differ. They are of the same magnitude. That's all. That is what is the meaning, nothing else.
So, there is one more question. Can you hear me, sir?
Yes, go ahead.
All right. As a teacher, I find difficulty to explain the need or importance of null hypothesis.
Gopi madam, interrupting. I asked her the question directly and he answered well.
Oh, okay, fine then, fine. There's no other question. Is there any other question, participants? Shiva Shakti madam?
Yes, ma'am. Yes, ma'am.
Could you locate any questions?
No, ma'am.
I think that's fine, right?
Yes, ma'am.
So,
What are thanks?
right. So, Rakesh sir, Miss, are you there?
Yes, ma'am. Yes, ma'am.
Yes, please.
Audible, ma'am?
Yes, sir.
Yes, please propose a vote of thanks.
Okay. It's my privilege to have been asked to participate a vote of thanks on this 5th webinar day. I, on behalf of the Dhubri College of Education, extend a very heartily vote of thanks to honorable delegates who blessed us with their presence. And I would like to extend a special thanks to Dr. Dayanand Sansal sir for their valuable presentation and valuable explanation. And also, I must mention our deep sense of appreciation, Dr. Shiva Shakti madam, Dr. Bobby madam, and Madam Hemlata madam, and Govindra sir, and After Dr. Basit Mases sir, Dr. Sujan sir, for making for this organizing this webinar. I extend my big thanks to Tamil Nadu Teachers Education University for their support. Thank you all the participants and all the panelists for making this event successful with their contribution. Thank you. Thank you all the teachers.
So thank you very much, Bobby madam.
Thank you.
Thank you.
Thank you. Thank you very much, Dayan sir, Dr. Dayanand sir. Thank you very much.
So nice.
Thank you so much, sir. Thank you so much for being with us, sir.
Thank you. Thank
It
you.
was indeed a faculty development program, sir.
I'm sorry that my video didn't work, but it's all right. No problem.
Yes, sir.
All right.
Yes, sir.
Okay, I'm leaving now.
Thank you, sir.
Right. Thank you so much, sir. Thank you so much, sir. What's up, sir? Thank you so much.
Okay,
Sir,
thank you.
so much.
Really?
Tomorrow, until we meet tomorrow morning once again, inshallah.
Right,
Thank
sir.
you,
Right,
sir.
sir.
Thank you.
Bye-bye. Bye-bye.
Inshallah, sir. Inshallah. Sir.
Bye-bye. Inshallah.
Right. Right.
Thank you, Dr.
And
Bobby,
madam,
ma'am. Thank you so much. Thank you
Yes,
so much.
yes. Shiva Shakti, madam. Thank you.
Dr. Govindra sir. Thank you, Mr. Ragesh. Thank you, Dr. Hemantha ma'am.
Thank you, ma'am.
Thank you, all the panelists.
Thank you. Thank
all the
you.
participants.
Thank you, ma'am. Thank you so much.
Thank you.